and YHWH HAMASCHIAC. Today we will be talking about love conservation of mass. And this has to do with some of our studies in YHWH HAMASCHIAC school. So take it as a documentary review. It's actually a study. Okay, so as I said, greetings in YHWH HAMASCHIAC school. We are on a study and more of documentary love conservation of mass for YHWH HAMASCHIAC school, concentrating on our syllabus for SS1 content. Then shall we pray in YHWH HAMASCHIAC school. May hard work ability forgive us where we've erred, even as we worship, and as we praise you, and as we adore you. And may He help us in our studies in YHWH HAMASCHIAC school. In a me, in a me, in hard work ability son, YHWH HAMASCHIAC. Okay, love conservation of mass. Actually, love conservation of mass is often referred to as the most fundamental concept of chemistry. Love conservation of mass is often referred to as the most fundamental concept of chemistry. This was put together by Antoine Lavoisier as a French name. The law of conservation of mass states that, before I continue on what it states, I said here that law of conservation of mass is often referred to as the most fundamental concept of chemistry, which was put forward by Antoine Lavoisier. In full, Antoine Laurent Lavoisier, born August 26, 1743, in Paris, is a prominent French chemist and he was a prominent French chemist and leading figure in the 18th century chemical revolution. I said Antoine was a prominent French chemist and a leading figure in the 18th century chemical revolution. He developed an experimentally based theory of the chemical reactivity of oxygen and co-authored the modern system of naming chemical substances. But we are not here to talk about his history. We are here to talk about him in regards to law of conservation of mass. The law of conservation of mass, according to him, states that, according to Antoine Lavoisier, states that in the process of a chemical reaction, the amount of matter involved remains the same before and after the reaction occurs. The law of conservation of mass, again, states that in the process of a chemical reaction, the amount of matter involved remains the same before and after the reaction occurs. In another translation, the law of conservation of mass states that the mass in an isolated system can neither be created nor be destroyed, but can be transformed from one form to another. As in another translation, what Antoine Lavoisier is saying is, what he was saying is that the mass in an isolated system can neither be created nor be destroyed, but can be transformed from one form to another. According to the law of conservation of mass, the mass of the reactant must be equal to the mass of the product for a low energy thermodynamic process. I'll take that again. The mass in an isolated system can neither be created nor be destroyed, but can be transformed from one form to another according to the law of conservation of mass. The mass of the reactant must be equal to the mass of the product for a low energy thermodynamic process. It is believed that there are a few assumptions from classical mechanics which define mass conservation. Later, the law of conservation of mass was modified with the help of quantum mechanics and special relativity, that energy and mass are one conserved quantity. In 1789, Antoine Laurent Lavoisier discovered the law of conservation of mass. So what's the formula of law of conservation of mass? Law of conservation of mass can be expressed in the different form using the continuity equation in the fluid mechanics and continuum mechanics. So as we go on, you can actually see the formula where P is the density, T is the time, V is the velocity. And the angle is the divergence. Law of conservation of mass examples. Combustion process. As burning of wood is the conservation of mass, as the burning of wood involves oxygen, carbon dioxide, water, and ashes. Chemical reactions, that's the second one. To get one molecule of water, that's H2O, with a molecular weight of 10, hydrogen with molecular weight of 2 is added with oxygen, whose molecular weight is 8, thereby conserving the mass. So let's look at the problem, law of conservation of mass problems. For instance, I'll ask that you refer to the notes. Question 1, 10 diagrams of calcium carbonate produces 3.8 grams of carbon dioxide and 6.2 grams of calcium oxide. Represent this reaction in terms of law of conservation of mass. The answer is, according to law of conservation of mass of reactants equals mass of product. Therefore, 10 grams of calcium carbonate equals 3.8 grams of calcium, equals 3.8 grams of carbon dioxide, 6.2 grams of calcium oxide, 10 grams of reactants equals 10 grams of product. Hence, it is proved that the law of conservation of mass is followed by the above reactions. So, therefore, to understand further, we take the following questions. 1. Why is there no change? Why is there no change? That's question 1 in mass during chemical reactions. Answer: during a chemical reaction, atoms are neither created nor destroyed. The atoms of the reactants are just rearranged to form product. Hence, there is no change in mass in a chemical reaction. Question 2. To verify the law of conservation of mass with an experiment, according to the law of conservation of mass, during any physical or chemical change, the matter is neither created nor destroyed. However, it may change from one form to another. Below we have listed an experiment that will help you verify the law of conservation of mass. Requirements: a shaped tube, also known as Landau's tube, sodium chloride solution, silver nitrate solution, in the other limb as shown in the figure. Both the limbs, please refer to your note, are now sealed and weighted, and the tubes are averted so that the solutions can mix up together and react chemically. The reaction takes place and a white precipitate of silver chloride is obtained. The tube is weighed after the reaction has taken place. The mass of tube is found to be exactly the same as the mass obtained before inverting the tube. This experiment clearly verifies the law of conservation of mass. So we ask question 3. If energy is neither created nor destroyed, what is the ultimate source of energy? And we say the ultimate source of energy in the universe of YHWH. YHWH means means the one without whom nothing exists. Elohim means the living word. So since Hayom means the one without nothing exists, he is the Big Bang. theory. That's the person that is being referred to. So like I said, the ultimate source of energy is the universe, or Elohim, presently in the Big Bang. That's not in your chemistry textbook. Take that from me. That's the truth. All the energy was created at the beginning of time, and as the universe grows, several stages of particulate matter developed, produced from that energy. By the time of the modern universe, the energy was distributed either into mass or kinetic energy or chemical energy in the lumps of matter or radiant energy. The masses are classified into galaxies and stars within them. The sun is one of those stars and get the energy from the primordial Big Bang. The Big Bang theory, by the way, explains, in contrast, cosmologists believe the Big Bang flung energy into all directions at the speed of light, 300 million meters per second, a million times faster than the H-bomb, and estimate that the temperature of the entire universe was 100 trillion degrees Celsius at any tiny fraction of a second after the explosion. So that's briefly what we have to talk about under the law of conservation of mass. See you soon.